Hey you guys, this is Mr. Sal. This is the integers and absolute value lesson. Our objective for this lesson is I can use integers to show or determine distance. We'll look at some temperature and money type examples as well. So let's look at integers first. We've got some integer action going on. Is 0 an integer? Well, let's find out, okay? So integers, let's look at some of the old classifications that you guys should be aware of before we get into this integer business. Now let's start first with these, what we call natural numbers. Now I know you guys think that's a hashtag, but it's not. It's a number symbol, which allows us to think and know that we're talking about numbers right here. And thank goodness that math people a long time ago were like, dude, I don't want to write natural number all the time. So they've created a symbol for it, and it's extraordinarily unique. Bam. Super fancy N right there. So natural numbers, the lowest natural number we know of is 1, because it occurs in nature. After 1, and this may come as a surprise to you guys, but it's 2. Next up, 3. Next up, I'm going to write 4. And actually, these go on and on forever, so I just get to put 3 dots to indicate that they do go on forever. All the way up until you get to infinity, which is so big, we can't really write it necessarily. Next up, after natural numbers, then we get whole numbers. So whole numbers are represented also by a super fancy W, like this. Okay, so in the future when you see that symbol, you'll have to know that it's whole numbers, because I'm not likely to write down the actual word whole number. Same with natural numbers. Well, whole numbers, as it turns out, include numbers like, I don't know, 1, and 2, and 3, and 4. And they go on forever, actually, which is pretty unique. But it looks pretty familiar, too, doesn't it? It's like, oh, dude, that's just some natural numbers. But there's one difference. 0. 0 is an extraordinarily unique number. In fact, it took people a long time to figure out what the crap it meant. Because, and I could be mistaken, but in some languages, it's like they didn't even have a word for 0. You just have to describe nothing. So natural numbers and whole numbers, it's important that you guys notice that there are no decimals. Okay. Now, does that mean we couldn't write these as decimals? We could. But these ones do not include decimal values. We just look at anything to the left of the decimal. Just throw it away. And then, also, I mean, we could represent these as fractions. However, we're not actually showing fractions like 1/2 or anything like that. So any values with decimals or fractions, such as those, would be considered not natural or whole. Well, that brings us then to integers, which is kind of a different set of numbers, such as 0, 1, 2, 3. Yeah, I'm going to continue. 4, 6, what? Yeah, 5 as well. And this goes on forever as well, to the right. And you may think, well, that seems like it's the same thing as whole numbers. That's because it is. However, we also must add their opposites. So not only are we going to the right of 0, but also to the left. So that'd be like -1 and -2. And -3, and then actually we show 3 dots going to the left as well to indicate that this pattern continues forever to the left. Well, seeing this written out like this, we should know then if 0 is an integer. So is 0 an integer? Yes. Yup. Now we could also ask the question, and we should ask, because we should ask lots of questions. Is 0 positive or negative? And it's important for you guys to know that it is neither positive or negative, because it has no value. So it is not classified as either positive or negative. So it's important to see in this list that all the natural numbers are contained inside the whole numbers as well, with that one individual difference of 0. And integers include all the whole numbers and natural numbers, but they also include all of their opposites as well. Now there's the symbol for integers, so that we wouldn't have to actually write the word integer all the time. And it by itself, and this shouldn't be a surprise, of course, is a fancy eye. Like this. Here's 3 examples for us. The first one, my son has grown 2 inches since his birthday. I spent $23 at McDonald's. I lost 8 pounds this summer. So what you guys should do on these is see if you can find an integer that accurately represents all 3 of these situations. But do it. Take 1 minute with your neighbor and talk about these. 1 minute, go! So if my son has grown 2 inches since his birthday, the accurate integer to show that would represent this situation is 2. Now, it's no need to show positive 2, which you could. But we need to understand right now that when numbers are positive, there's no need to show the positive sign on it, okay? So I would just write the number 2. Now, if you labeled it, that's fine as well. But I'm just going to write 2 because I'm a lazy math guy. Next up, I spent $43 at McDonald's. Now, we know you're spending 43. It's just a matter of, well, are we talking about positive or negative? It was money spent, which means that you lost it. And losses are always represented, usually anyways, by negatives. So the same thing would work on the third one here. I lost 8 pounds this summer. So we know it's 8 total, and it's a loss, which means it would also be negative. All right, when we graph integers, we can use a number line like this one. It's horizontal, but sometimes use vertical as well. And if we looked at any integer, we'll figure out one that fits. Let's look, I don't know, just randomly. This is -4. I said, identify or graph -4 on this number line. Really, all you're going to do, you guys, is put a dot where -4 is. And right here, if we follow the number line, we got 0, then this would be -1, and then -2. And then the next one, -3. And then this next line on the number line would be -4. So I'm going to put a dot at -4 right there. We'll do one more. What about, 8, right? So let's graph 8. Well, 8, that's positive, which is to the right of 0 on the number line. All negatives are to the left of 0. So on this number line, we got 0, then 1, then 2, then 3, 4, 5, 6, 7, and bam, I found 8. It's right there. All I got to do is put a dot on that number line. All right, for absolute values, direction does not matter. I'll explain more about this here in a second. It's also the distance from the starting point, which should be 0, really. And absolute values are using a different symbol that you may not be as familiar with, but it looks like this, okay? Now, usually there's some kind of value or variable between those two symbols, and they're just straight lines, straight up and down. In terms of the order of operations, we treat these like we would parentheses, all right? So, absolute values are really asking this question: how far is the value from 0? So you'll see something like this where, like this, I'll just use those absolute values. I don't know, something like 3, okay? So this reads the absolute value of 3. However, the question is really asking, how far is 3 from 0? And hopefully we know that it's 3 from 0. It's pretty direct, okay? Now let's look at this in the other direction, though. So how far away is -3 from 0? It's still 3, you guys, because again, remember, direction does not matter. It's just asking distance. How far away is it from 0? And distances, as it turns out, is always referred to in the positive, because if you start referring to distances in terms of the negatives, then people start, calling the funny farm on you, and then they take you away. And then we may not see you till after Halloween. Like, for example, like this, okay? Like, if I said, you know what, I live -40 miles north from Salt Lake. You could confuse a lot of people, and maybe you could become a really good politician that way, all right? But in any case, it's not how most people talk. We don't expect you to talk that way, because distances in terms of negatives, it's like, you weirdo, call the funny farm, take them away. All right, here's a picture of an odometer. It's not my odometer. It's someone's. And if you drive I'm going to read the questions here. If you drive 2 miles, what will the odometer read? If you put the car in reverse and drive 2 miles backwards, what will the odometer read? Odometer doesn't care what direction you drove. Odometer only cares how far a car went. Sound familiar? odometer is everyday example of absolute value. But take a look at that. The odometer is this right there, by the way. So just think about that. If you were to take this odometer and you drove 2 miles, then what would it read? Let's do that one first. Well, let's do both of them at the same time. We'll do them together. What the heck? So, if you drive 2 miles, what will it read? Well, right now it's showing, and if we showed the commas on that, because it may be, no, not right there. That would be like a decimal. And then this is a comma right there, okay? So that's reading 159,087.7 miles. And if I drove 2 miles, then suddenly the odometer would read, right, we'd just add 2 to the 1's place value. And next thing you know, we would have 159,089 miles. 0.7, sorry, I'll put the 0.7 in there. 0.7 miles. It's like, that's pretty sweet. I like that question. But then it says, if you put your car in reverse and drive 2 miles backwards, what will the odometer read? It's not going to make a difference, you guys. It's still going to add another 2 miles to that. Yeah, odometer doesn't care if you go backwards or forwards. It's still going to count it as miles driven. So this one now is going to show as that's on there, 159,091.7 miles. Okay, because it doesn't matter if you go backwards to this odometer. It's like you're going some distance, and it's going to read that as distance gone, which, like it says at the bottom, is an everyday example of absolute values, even though you guys aren't driving yet. Maybe some of you guys are, but most of you aren't. So again, the notation for absolute value is those 2 straight lines up and down like that. And again, it's always the distance from 0. The distance from 0 is the absolute value. So what do we know about absolute value? Just based on what we've seen, right? Absolute values are always positive because it's weird if you start talking about distance in the negatives. And then they'll take you away. So take a look at this list of values. We got that. I'll read them. The absolute value of -4, -1, -11, the absolute value of -12, and then the absolute value of 7. All right, just take a minute. See if you can order these from least to greatest. All right, let's do it. Now, before we put these in any kind of order, I actually want to know what the real values of these are. So I'm going to manipulate them outside of the absolute value so I can see its total or actual value. So the absolute value of -4 is 4, because -4 is 4 away from 0. -1's fine, and so is -11. But the absolute value of -12, how far is -12 from 0? Is 12. Yeah, and how far away is 7 from 0? Is 7. Okay. So now I have a list of values without any absolute values that I can now put in order from least to greatest. Okay. So the least number that I can see on this is, it's negative. -11. Bam, I used it up. Now, when it says least to greatest, it may be helpful, and this, you could use this if you wanted to, a number line, okay? I put 0 in the middle or towards the middle, close to the middle as I can, all right? And I know that -11 would be farther to the left than -1, because -1 is pretty close to 0. So that's why -11 is the least number on the list. Next up is -1. Bam, I used it up. Okay, now the other numbers that we have, 4, 12, and 7, we got 3 numbers, and the one that's farthest from 0 is 12, and then 4 is closer to 0 than 7, like this. Now that's not proportional, but I don't give a crap, because it still identifies where these numbers are in relationship to each other and 0. So when I list these as well, I list the original value that it showed us. So the next least number is not 4, it's the absolute value of -4, just like it listed in the beginning. Okay, so I'll emphasize those absolute value symbols. And then next up, again, it's not 7, it's the absolute value of 7. And then finally, not just 12 or -12, the absolute value of -12. Okay, and now I have listed all 5 of these in order from least to greatest. All right, here's 3 questions for us. Insert the correct inequality, so that's a less than or greater than for us, maybe equal. And then B, which represents the largest debt, and C, which represents the deepest hole. Work with your neighbor on this one. Well, all 4 of these. 1 minute, go! So we'll insert the correct inequality, and we'll talk more about inequalities in later units, so I'm just going to kind of breeze over this. But let's evaluate these first so we know exactly what the actual values of these are. The absolute value of negative 20 means that negative 20 is 20 away from 0. And the absolute value of negative 7 is asking how far away is negative 7 from 0. That's 7, you guys. Now, evaluating the red numbers instead of the original ones they gave us would show, obviously, that 20 is greater than 7. So this one indicates that the absolute value of negative 20 is greater than the absolute value of negative 7. We'll do the same thing on this next problem. The absolute value of negative 5 is 5 away from 0. And negative 21 is 21 away from 0. The absolute value of it is. So, this one, I can see 21 is much bigger than 5. Therefore, negative 5 absolute value is less than the absolute value of negative 21. Next up, part B, which represents the largest debt. So, I'll read all 3 of these. An account balance of negative 5, an account balance of negative 7, and an account balance of negative 20. So, negatives are debt, so debts are negatives, generally speaking. So the biggest one that I can see is this one, the most amount of debt. So part C, which represents the deepest hole. Now it's not saying the hole is negative 21 feet deep, because that's like a double negative thing, which would be a kind of like double opposite. So we're just saying that the hole is these number of feet deep. And as far as I can see, 22 is the biggest one. So it would be by far the deepest hole amongst these 3 options. So here are the next 2 problems. Simplify both of these. Work with the neighbor. 1 minute, go. All right, right here I got the absolute value of 2 minus 4. Now if we remember, like I told you guys, that absolute values act like parentheses, which means that I have to actually evaluate what 2 minus 4 is first. So 2 minus 4, I'm taking away more than I have, so I know I'm going to end in the negatives. Well, how far? That'd be 2. All right, so right now I have the absolute value of negative 2. And negative 2, I know, is 2 away from 0. So the final answer to this one is 2. That's fully simplified. Next up, I'm going to simplify the absolute value of 1 plus 3. And I know, again, I'm just going to evaluate 1 plus 3 first, which is 4. But it's the absolute value of 4. And I already know that the absolute value of 4 is asking how far away 4 is from 0, which is 4. So there's our 2 answers for this. All right, I'll read this one. Part A, on your ATM receipt, you notice that your account balance is negative 17 bucks. Which statement is true about the amount of money in your account? And then part B, if the temperature says negative 11 degrees, how many degrees below 0 is it? So see if you can find the answers to these 2. 1 minute, go! So we'll do part A first, where we're trying to figure out which is true about the amount of money in the account. This first one says there's no money in the account. Well, supposedly, but I mean it's owed money, so it's not that there's no money, it's actually owed money, so that one's, oh, that's not what I have to do. No money is false. You took out $17 more than you had, and now you owe 17 bucks. Well, a negative would indicate owing some amount of money, so yeah, that one sounds pretty good. Like maybe there was $0 and then you spent 17 bucks out of your account, or you know, it could have been some other amount, like you had 17 bucks in your account, but then you spent 34 bucks, something like that. So you just now owe 17 bucks essentially to the bank. Well, this next one, and by the way, if you guys were to analyze that statement, it said which statement, right? So some of you guys were asking, well, could there be more than one? I suppose, but it said which statement, which is singular. So there should only be one correct answer on this one. But let's analyze the rest of them just to make sure, okay? It says you have a balance of 17 bucks. Nope, it already said it's a balance of negative $17, and it is different. Your debt is $17. Yeah, that should be good. So even though it sounded like it was singular, that's weird. That seems extraordinarily deceptive. So yeah, I would say that your debt is actually 17 bucks as well. because it's amount owed. Debt also would be another way to show negatives. In order to have a positive balance, you will need to deposit more than $17 into your account. Yeah, if you deposited more than $17 in your account now, then you would also have, or your account balance would be in the positives. So yeah, that'd be true. If you deposit 17 bucks, you will have $17 in your account. Nope, that's false. Because if you deposit right now $17 in your account, you're going to have $0. Because the bank's going to take that immediately. Probably make you pay a fee of some type as well. Next up, part B. If the temperature says negative 11 degrees, how many degrees below zero is it? 11 degrees. Now, by the way, on this one, this is a word problem. Not asking specifically for integers. So not only am I going to say 11, but I'm going to label it with the degree symbol right there. Okay? So it's 11 degrees, and you could write below zero if you'd like. But that's more writing that I'm going to do. Real quick. Sophie and Jack both ride their bikes to the mall. When it's time to go home, Sophia makes a left out of the parking lot and rides 6 miles west of the mall. Jack makes a right out of the parking lot and rides 6 miles east of the mall. So in cases like this, especially word problem, it may be nice to show a diagram. And that's the mall, by the way. So I'd start with Sophia on this one, who's going to take a left out of the parking lot and ride 6 miles west. So she's going to go to the left right here, whether that's west, doesn't really matter. But she's going to go 6 miles. Bam, right there. Now, who was it? Jack? Jack is going to go to the right out here, and it's another 6 miles. So it's saying, well, it said who rode their bike further? Nobody. It's the same, yeah. It's the same. Nobody. It's the same amount. However you want to write that, it's fine. But the next question that should come up is, well, how far apart are they? That should be easy to find because Sophia is 6 miles to the left and Jack is 6 miles to the right. So 6 plus 6 would indicate that they are 12 miles apart. There's our objective again. We should be able to use integers to show or determine values of distance, but just values in general as well. Like we did see some debt and money type examples, which is pretty good. And temperature as well. That was pretty good too.